Hey math fans, welcome to chapter 3, section 6, perpendiculars and distance. I'm going to split this section up into two videos. In this video, I'm going to go over calculating distance between a line and then a point that is off that line, not on that line, but parallel to it. So what we're going to do is we're going to write an equation of a line, and then we're going to write an equation that runs perpendicular to that line that contains the point that's given to us, and then we're going to calculate the distance between that point that was given to us to that line that we created. So it sounds kind of weird, but hopefully after these two examples you feel like you get the hang of it. So with that being said, let's just dive right in. The first thing I wrote at the top of the notes is that the perpendicular distance between a point and a line is the shortest in all cases. So if I draw, conceptually speaking, if I draw a line and I give you a point off that line, and I say what's the distance between that point and that line, the shortest distance would be to calculate the perpendicular distance to it, right? You wouldn't want to, let's say, do like a long diagonal line. Remember, like your rules of your triangles, the hypotenuse is the longest leg of the triangle. So if you do like a diagonal line, you're traveling a farther distance than this perpendicular line going from the point to that line. So that's kind of, conceptually speaking, that's what we're doing in this video. So example 1 says line L contains points -5, 3, and 4, -6. Find the distance between line L and point P at 2, 4. So in step 1, we're going to calculate the equation of line L. So remember, to calculate your equation, it's going to be in slope-intercept form, y equals mx plus b form. And so you'll need to get your slope, and you need to know your y-intercept. So the first thing is to figure out your slope. So your slope uses the 2 points that you're given. And remember, you got to label them x1, y1, and x2, y2. And remember, your slope formula is going to be y2 minus y1 over x2 minus x1. So I'm going to write -6 minus 3 over 4 minus -5. So that's going to give me -9 on top and +9 on bottom, which will equal -1 over 1. Or anything over 1 you could just write as a whole number, so that'll equal -1. So that's my slope. Okay, the next thing I need to do is figure out my y-intercept. So I'm going to turn my attention to that y equals mx plus b formula, and then I'm going to use the first point I'm given. You could use the second point if you want, but I'm going to use the first point I'm given to plug in for x and y, and then I'm going to use -1 to plug in for m. So it's going to look like this. Instead of saying y equals, it'll say 3 equals -1 for m times x, that's -5, plus b. So that's going to turn into 3 equals -1 times -5 is +5 plus b. So I know that 5 minus 2 is 3, or you can just, if you want to show your work, subtract 5 to the other side and get -2 equals b. But now that you know your m and your b, then you know your line is going to be y equals -1x minus 2, or simply just y equals -x minus 2, since you typically will not write a 1 in front of an x. So believe it or not, that was all just step 1. So step 2 is going to be write an equation of a line perpendicular to line L. This is line L, using point P. Okay, so we were given point P up here, 2, 4. And the line needs to be perpendicular, meaning your slope needs to be perpendicular. So my perpendicular slope from the previous line, well, the previous slope was -1, right? So flip that, that's going to be +1 over 1, opposite reciprocal, right? Or you could just write m equals 1, okay? So if m equals 1 and p is at 2, 4, use that for your x and y, and plug it into your y equals mx plus b formula. So we're going to write down y equals 4 equals m1 x2 plus b. So that's going to give us 4 equals 1 times 2 is 2. So 2 plus b equals 4. So if you want, show your work by minusing 2 to the other side, but you could do this one in your head. 2 plus 2 is 4. So b equals 2. Okay? So what I've determined now is I have my perpendicular slope of 1 and my y-intercept at 2. So I'm going to write y equals 1x plus 2. Or like the first one, I'll just drop the 1 and I'll write y equals x plus 2. And so this is my perpendicular line. Okay, so now we have our original line, and then this is a line that runs perpendicular to it and will contain the point P. So now we need to get the intersection of that. So if you're using a TI Inspire, you'll want to graph both of these and then do menu analyze intersection. For me, I just use Desmos. All you have to do in Desmos is graph both lines, and then you just tap where they intersect. So they intersect here at -2, 0. So I'm just going to write -2, 0 on my intersection blank right here, and I'll call that point Q just to give it a name, okay? And so what I'm going to do now is I'm going to calculate the distance between points P and Q. So remember, P was the point that was given to you in the very beginning at 2, 4. Q is the point that we just figured out at -2, 0. And so to calculate the distance, we must use the distance formula. So it says x2 minus x1 plus y2 minus y1, and then you square both of those differences, and then take the square root of that when you sum them together. So I just use these, the points for P as x1, y1, and the points for Q as x2, y2. So I'm going to write 0 minus 4 squared plus -2 minus 2 squared. Make sure all that's typed underneath the square root sign. It's called a radical. And you feel free to type this in all at once, because on my assignments at least, I'm going to ask you to round to the nearest thousandths place rather than simplify the radical. It depends on what your teacher's asking you to do. If they're asking you to simplify the radical, well, you do this part first. That's -4 squared. That's positive 16. And then you do this part second. That's going to be -4 squared again. So it's also positive 16, which is going to be square root of 32. And so if you wanted to simplify the square root of 32, it would be 4 square root 2. But for my students, I say, hey, just type in this top part and then round it to the nearest thousandths place. So when I ask you to round to the nearest thousandths place, I'll need to look at those third and fourth decimal places. So if this is 5 or bigger, it's going to round this number up. So instead of saying 5.6568, I'm going to say for my answer 5.657. And that's going to be my final answer. That's going to be my distance. It's the same thing as this if you type that into the calculator, or this if you type that in, or this. You get what I'm saying. So that's the final answer to this problem, okay? So that's kind of a lot, I understand. So I'm going to do one more example, and like I said, hopefully it built your confidence after seeing these two examples. Okay, so example 2 says, line S contains points -4, 14, and 6, -1. Find the distance between line S and point V at 6, 7. So if I'm going to use the same steps as I did before, I'm going to calculate or create the equation that runs between these 2 points. So the first thing I need to do is figure out my slope. So I'm going to label my points as x1, y1, x2, y2, and use my slope formula here. So I'm going to have -1 minus 14 over 6 minus -4. And so -1 minus 14 turns into -15. And then 6 minus -4 turns into 6 plus 4, so that's 10. And so -15 over 10 can simplify. They can both be divided by 5, right? So this turns into -3 over 2. You could put this into a decimal, and that would be -1.5, but it's a slope. I prefer slope stay as a fraction, so I'm just going to write negative 3 over 2 equals m. All right? So that's the first step. Second step is to figure out the y-intercept. So I need to use one of these 2 points. I usually just use that first point given to me. And so I say y equals mx plus b. And I know that y will be 14 from that point, negative 4, 14, equals m is negative 3 over 2 times x is negative 4 plus b. So negative 3 over 2 times negative 4, that'll equal, if you multiply the top times negative 4, that'll equal 12. 12 over 2 equals 6. So I have 14 equals 6 plus b. That's how you do fractions in your head, by the way. Multiply the tops, then divide by the bottom. So subtract 60 the other side, or you could probably do it in your head. 6 plus what number is 14? But 14 minus 6 is 8, so b equals 8. All right, so now I know my m, now I know my b, so I can write my equation for that line. It's going to say y equals negative 3 over 2x, and then b was positive 8, so I'm going to write plus 8. Okay? So now I need to do the perpendicular line, or the line that goes perpendicular to it, that contains point V, 6, 7. So I have to turn my attention to the y equals mx plus b again, and I'll use this for x and y. And then remember, my slope now, I need to do the perpendicular slope, right? So my slope before was negative 3 over 2. The perpendicular slope is going to be opposite reciprocal, so positive 2 over 3. Okay? So now I do the y equals mx plus b, and I say that y equals is 7 equals, m is 2 over 3, x would be 6, and then plus b. Let's see here. So 2 over 3 times 6, that would, if you multiply the tops, that would be 12 over 3, that's 4. So 7 equals 4 plus b. So 4 plus what number is 7? 4 plus 3, right? Well, you could also show your work by subtracting 4 to the other side. 7 minus 4 is 3, so 3 equals b. So if b equals 3, and then you know your m is 2 over 3 because it has to be perpendicular, right? Then your perpendicular line is going to say y equals 2 over 3x plus b of 3. So what you need to do now is graph these two equations that we got and then get the intersection. So when I graph my two lines, negative 3 over 2x plus 8 and then 2 over 3x plus 3, and then I graph it in Desmos and just tap where the intersection is, this is what it gives me. This is probably a rounded number, but that's okay. It's good enough to calculate the distance for this problem. So what I'm going to do is I'm going to calculate the distance between this point here and then point V right there. I'm going to use those 2 points in my distance formula. So I'll use the points of V for x1, y1, and then I just titled the intersection point Q just to give it a name. I'll use that for x2, y2. And so you use the distance formula, so you're going to say that you're going to take the square root of, and then you're going to do y2, 4.538 minus y1 of 7 squared plus x2 is 2.308 minus 6, and that's squared. So all that's under the radical. Remember, when you get your answer, it should always be positive. If not, you'll get likely an error message. If you got that, you got a negative number in the inside of your radical here, that means you probably forgot to put parentheses. But anyway, when you type all this into your calculator, you get approximately 4.4376. So if I want you to round this to the third decimal place, I'll look at the third and fourth numbers. So does this 6 round up to 7? Yes, it does. So I'm going to say it equals, or it's approximately equal, using the squiggly equal sign, 4.438. And that'll be my distance. Okay? So that's it for the second example. I hope you feel like you learned something. So thank you for watching, and goodbye.